Now in this lesson, we are now looking at the third variation of our test diagram sums. Here we will give you an equation that you have to simplify and write it in a ratio. So let's look at the problem. So if 5 sine theta plus 4 equals 0, and my restriction theta is less or equal to 270 greater or equal to 0, calculate the value of sine theta minus cos theta. So again, first now we will have to simplify that and make sine theta the subject of the formula. So that would, alright, so if I take plus 4 over, that becomes negative 4, and we always divide by whatever coefficient is attached to sine. So sine theta then becomes negative 4 over 5. Again, we need to understand that sine theta is y over r. So my y value there is given as negative 4 and my r value as 5. So from this we must find x using theorem of Pythagoras. Alright, so now our restrictions say theta less than 270 greater than 0 degrees. Now sine is negative. So 0 to 270, 0, 90, 180, 270. So we're working 1, 2, 3 quadrants. That quadrant sign is positive, their sign is positive. So the only quadrant where sign is negative is in this quadrant. Remember, sine theta equal negative 4 over 5. So theta will always be closest to the origin, right? From there, my y value, negative 4, and my r value, 5. Using theorem of Pythagoras, r squared minus y squared, 5 squared minus 4 squared. That gives me plus minus square root 9. And then x will then equal minus 3, or x equal 3. Now in the third quadrant, you can see positive x is to the right of the Cartesian plane. So here x is negative, so my x must then be negative 3. So 1 mark there and 1 mark there, you got 2 marks. Now you're done with the difficult part. Now we're just solving the problems. Right, so x is minus 3, y is negative 4, and r is 5. So to solve that, sine theta, remember, is y over r, so minus 4 over 5. Cos theta is x over r, which is minus 3 over 5. So minus 4 over 5 minus 3 over 5. That would give me negative times negative, which is positive. Denominators are the same, so minus 4 plus 3 gives me minus 1 over 5. Right, let's look at the second problem. Right, now here in the second problem, they say if tan A equal P, and A, that angle A is less or equal to 270, greater or equal to 0, determine the value of 1 minus cos squared A. Now this is a favorite of catching you out. You need to remember anything divided by 1 stays the same. So first, if we solve that, I can rewrite tan A as P over 1. Right, then from tan I need to know tan is always y over x. So therefore, P or y equal to plus minus P, x can equal plus minus 1. Right, the plus or minus is dependent on which quadrant we're writing in. Tan is positive, so we have to go look where tan is positive, so we have to find r using theorem of Pythagoras. Right, now tan is positive, so in short I can draw it in there. I should have written there 90, but I've drawn it. Solve it in the third quadrant, so you can see how we double catch you out testing this in exam. So we have r squared equal x squared plus y squared. Right, now in the third quadrant, although we wrote tan as positive, it's positive because it's y over x, and negative divided by negative is positive. So you see there, x I put in as negative 1, y then negative p squared will stay positive p, right? So that becomes r squared becomes plus minus square root 1 plus p squared. But remember, r must always be positive, so it will be square root 1 plus p squared and not equal to the negative. So I hope you understand. So when I write that, it's negative p, negative 1. But because I'm squaring them, they make no difference to solving r. The negative will become positive. Right, so 1 minus cos squared. Remember, cos is x over r. My x value there was -1. My r, square root 1 plus p squared all squared. So -1 squared would become 1. Square root and square cancel, so I'm left with 1 plus p squared. Right, to add two fractions, denominators must be the same. So therefore I write 1 as 1 plus p squared divided by 1 plus p squared. Anything divided by itself will always give me 1. So from there now the denominator stays 1 plus p squared. But if I add my numerators, 1 minus 1 cancel, and I'm left with p squared. Right, so I hope you enjoy the lesson. I hope you understand. Feel there's anything I need to do differently, or you want to explain, or you have your own problem that you feel I must answer, leave it in the comment section and I will gladly help you. Right, I wish you nothing but the best. Please subscribe.